Is this working?
Can you hear us?
Can you hear me?
Yeah.
Can you hear me?
Yeah, all good, all good.
1, 2.
Yeah.
To me, to you. There we go. How's everyone doing tonight? Great? Oh, wow, you're not great, are
That's
you?
a good cheer, yeah.
How's everyone doing tonight? There we go. Welcome to Google. I have the pleasure of welcoming you to our Google HQ. My name is Mike. I am one of our startup lead covering UK and Ireland, and I have the pleasure of working with some great, fantastic startups. One of the, although maybe not so much of a startup, but one of the startups that I have the pleasure of welcoming and looking after is Pydantic.
Yes. Hey everybody, I'm Dennis Casey. I'm an AI lead for Google Cloud startups in the UK. It truly is a special moment to have so many builders in a room that are effectively shaping the agentic experience for many of the consumers and businesses that we are going to see in the near future. So this is a special one for us. Thank you for being here. So for us, community is quite important, especially at Google Cloud. And I appreciate London doesn't have a big AI community. It's a bit fragmented, so hopefully we'll be able to change that soon. So over the next hour or so, we have a super action-packed agenda. Mike's going to talk over that in a bit. But before we do that, I just wanted to do a quick pulse check. Who here uses Gemini? Raise of hand. Yes, this is a good turnout. Mike, we still got some work to do.
Yeah, there's a few people here. There's a few people.
Which is great. We will change you, but you guys are, Gemini gems. I love that, so that's great. Another quick, show of hands. Who here knows Pydantic, uses Pydantic?
There we go. I think there was more hands up for that.
Yeah, like a big fan of Pydantic. I like that.
That's good.
I like that. On that note, over to you, Mike.
Right.
The agenda.
We're going to quickly go through the agenda. You've probably all seen it, but we have an action-packed agenda, as we've said. So first, we're going to hand over to Paige Bailey, who is our Developer Experience Engineering Lead at Google DeepMind. That's going to be a great talk. We're then going to go over to David on observing and optimizing an agentic app. And last but not least, MCP is all you need from the founder of Pydantic. So you've got that to look forward to. And then we have a special announcement just for everyone in this room. No one else is going to hear about this until after today. And then we're going to wrap up with a slight Q&A, so you can ask some of your questions. And then we're going to wrap up. I'm going to head back downstairs for more networking, so you can speak to the Pydantic team and speak to the Google team. You all excited? You ready?
Give us a cheer.
Well,
yeah. Great.
Keep that round of applause going. Paige Bailey, thank you.
Woo! Go for it.
Excellent.
Thank you very much.
Thank you. Greetings, everyone. It's great to be here today. I'm really excited to tell y'all a little bit about what we've been building at Google DeepMind. There's a lot coming from the API's perspective, a lot of goodness also in terms of collaborations with Pydantic, support for things like MCP servers and the like. So with that, would it be possible to toggle over to the main presentation? I will watch expectantly until it goes. There we go. Amazing. So generative AI is definitely transforming everything that we do at Google. It's changing how we build our products, how we ship them, how quickly we can get them into market. And we have been especially experimenting with this over the course of the last 9 months. We have a few flagship models that have been recently released. Gemini 2.5 Pro. How many people have just used this a little bit in your projects? Cool. VO3, show of hands, seen it floating around on TikTok, video generation. Awesome. And then Gemma 3N, which is one of our open models. Few hands there. Okay, cool. So by the end of this presentation, hopefully I will convince you to use one or all of these models. Gemini is a little bit special to all of us at DeepMind, but also in the world in the sense that it's designed to be natively multimodal, which means that it can understand video and images and audio and text and lots of different things like PDFs. But it can also output multiple modalities. And it can output this with the same exact model. So in addition to text and code, you can also output images with Gemini. You can edit images. You can output audio, including audio in multiple languages. And you can also steer it in quite a few different ways. So this means that if you give Gemini an image of a car, you can ask for it to be turned into something like a convertible, which we'll take a look at in a second. You can ask it to whisper in a tone. You can ask it to speak in German or in Spanish dynamically, and the like. I'm also going to show something that you can build today with commodity APIs that are available in AI Studio, and then we'll get into some demos.
I'm here with the latest research prototype of Project Astra, and we're going to see how it can help me fix my bike. Hey, go online and look for a user's manual for a Huffy mountain bike.
I have found a user manual for you. What would you like to know about it?
Okay, cool. Now scroll until you find the section about the brakes.
Sure thing. Looking for that page now.
I think I stripped this screw. Can you go on YouTube and find a video for how to fix that?
Of course. I'm opening YouTube now. This looks like a good video.
Place a rubber band over the head of the screw.
Oh,
and
nice.
press down
Thanks.
firmly.
Can you go through my emails with the bike shop and find which size hex nut I need?
Sure. According to the email from Bicycle Habitat, you need a 3/8 inch hex nut for your sprocket. I've highlighted the correct bin for you.
It seems like I need a spare tension screw. Can you call the nearest bike shop and see what they have in stock?
Yep. Calling them now. I'll get back to you with what they have in stock.
I think my brake pads are wearing down. Can you check the manual again and see if it talks about them anywhere?
According to the manual, if you look on page
Hey.
24,
Do you want to get lunch?
Yeah, give me 5 minutes. Can you finish what you were saying?
as I was saying, if you look on page 24, section 2, you'll see how to replace the brake pads.
Hey, any updates on that call?
Yep, I just got off with the bike shop. They confirmed they have your tension screw in stock. Would you like me to place a pickup order?
Could you show me some examples of dog baskets I could put on my bike?
Sure, I can help you with that. Just give me a moment. Here are some options. I think Zuka would look really great in these.
Cool. So as mentioned, all of this you could do today just using the APIs that we have available via AI Studio. This is what's powered many of our different Google Glass style experiments that you might have seen at I/O. In the interest of time, I'm not going to go too awful into these, but you can start building these experiences. Like if anybody's a Hitchhiker's Guide to the Galaxy fan, the Babelfish, where somebody's speaking in an alternate language, you can hear it in your own native language. Again, possible today, just using the Gemini APIs. We've also been putting it on robots, so particularly using Gemini Live to orchestrate calls to other smaller models or more special purpose models. But it takes into account reasoning, it takes in the video and audio input feeds, and then behind the scenes, it generates code in order to run the robot to accomplish different tasks. So most of us have been thinking about agents in the sense of browser-based systems or systems that might just be on our own personal computers, but these are actually agents running in an embodied way, which is pretty rad. So with that, I'm going to go ahead and get into some demos. And I just want to keep underscoring that Gemini, just the API itself, can be used for everything from image understanding to video understanding, speech to text, text to speech, transcriptions, translations, and all of the above, just within the browser itself. Cool. So how many people have seen AI Studio before? Oh gosh, like that's the homework for tonight. So the AI Studio is the best place to go to get access to the DeepMind models as soon as they come out. It is kind of a one-stop shop, everything from the generative media models, so imagine, VO, but also Gemini 2.5 Pro. You can use it for free. You can access it with your personal Gmail account. And once inside AI Studio, you can do things like select different models. So you can see here some of the Gemini 2.5 series. You can see the pricing for their inputs and outputs. You can do things like that example that I was showing just before. You can kind of select different model types. And then you can also test out features like speech generation. So text-to-speech, folks might have been using 11 Labs. I could say read aloud in a warm, welcoming tone, like a California surfer. Surfer dude, and then say we're excited to show you our native speech capabilities. They're really gnarly. And I'm going to select a couple of different voices. So here we have multi-speaker audio. I'm going to select Corey and Puck, and then hit run. And one of the nice things about AI Studio is that whatever you do in the UI, if you can get it to work within the UI, if you click this Get SDK Code button, it gives you a copy and pastable code snippet. Let's try this again. It gives you a copy and pastable code snippet to accomplish whatever you just did. So you can see the speech config, the multi-speaker speech config, some of the chunking associated, the curse of live demos. Let's see if we can try it with streaming and see if that might actually work. Hey Gemini, could you please tell me what you see on the screen?
I see a web page titled React Agent from Scratch with Gemini 2.5 and LangGraph. The page discusses using LangGraph to build React agents for large language model applications.
Excellent. Could you tell me a little bit about Pydantic? I see Pydantic is listed there as a base model.
Pydantic's base model is mentioned on the page as part of the state shared data structure component for LangGraph model agents. This indicates that base model is used to represent the current snapshot of an application's state.
Excellent. And could you tell me a little bit about the Gemini APIs as well?
The web page has a link to Gemini API docs in the top left corner, suggesting that the Gemini API is a set of tools or services for developers.
Yeah.
It also mentions that VO3 is now available in the Gemini API and links to learn more.
Yeah. Excellent. You can also start new streams. So if I was going to start a new stream, select something like Spanish, and then share screen again. Hey Gemini, could you please explain in Spanish what you see here on the screen?
Claro. En la pantalla veo un artículo titulado React Agent from Scratch with Gemini 2.5 and LangGraph, que explica cómo construir agentes React usando Gemini 2.5 y LangGraph. También menciona que LangGraph es un buen marco para crear aplicaciones LLM con estado.
So I don't speak Spanish that well. That seemed like it was right. Hopefully it was. If not, that would be embarrassing. But as mentioned, if you click Get SDK Code, you can see the model referenced here. You can see how you would go about using it in your project. And it's just kind of a copy and pastable code snippet for you to go ahead and get started. You can also select different voices. You can select different tools that you can use out of the box. And so as an example, if I were going to say something like, hey, Gemini, could you tell me what the temperature is in London or wait a second.
Lo siento.
Let me try again. Hey, Gemini, could you tell me what the temperature is in London today?
The temperature in London, UK, is currently 75 degrees Fahrenheit or 24 degrees Celsius, and it feels like 76 degrees Fahrenheit or 25 degrees Celsius. It is partly cloudy with a 0% chance of rain.
Yeah. Do it again. Do it in Spanish.
La temperatura actual en Londres, Reino Unido, es de 24 grados Celsius o 75 grados Fahrenheit, y la sensación térmica es de 25 grados Celsius o 76 grados Fahrenheit. Está parcialmente nublado con 0% de probabilidad de lluvia.
And so one of the nice things is that if you select a native language, so something like Spanish or German, if your sort of respondent speaks to you in English, it'll respond in English. If they ask you to speak in a different language, or if you specify in your system instructions to speak in that language, you can change it dynamically. And so again, you can see kind of the executable code pulled in as a function call. And if you click the Get SDK Code button, you can kind of incorporate it into your project along the way. But search is a tool baked into the API itself. We also have URL context, so you can add links to specific sites, kind of like poor man's retrieval, and other kind of function calling that you can bake into the API itself. Relatedly, we've just announced a build feature within AI Studio. So you can do things like, say, if I zoom in a little bit, build an app that creates a unique Magic the Gathering card. Each time the user asks for a new card, make sure to use Imagine and the Gemini APIs for the app. And then If you click Control Enter, you're immediately launched into this thing that looks kind of like a UI for like v0.dev or Lovable or something similar, like a bolt. You can expand out the thinking section. So this is Gemini 2.5 Pro's kind of behind the scenes logic of what it would be requiring to do to build this app. Since it's grounded on all of the latest APIs and models, it selects the best one for the task. So Gemini 2.5 Flash. It incorporates the card art. If I zoom out, you can see some of the code that's getting written off here on the screen. So the TypeScript getting created. All of the apps are React apps. And if the model kind of runs into a problem along the way, it'll flag it as an error and then go about fixing its error. So it's kind of cool to see the model kind of test out all of these things in real time. And then even better, once the app gets created, it's visualized on the screen, but there's also a native deploy to Cloud Run feature. So you can take whatever app you've just created and immediately get a URL that's unique that you can share with your friends. Cool, so let's see if this actually works. I'm gonna hide this for a second. Powered by Gemini and Imagine. Crossing fingers, painting the artwork. There we go. So temporal weaver, flying, time is not a river. For people who have not played Magic the Gathering before, this does look like pretty reasonable for some stretch of the imagination. If you click Deploy to Cloud Run, all you have to do is select a cloud project. So I'm just going to arbitrarily select this one, deploy it, deploying to Cloud Run, which will also kind of obfuscate away all of the API keys, so you can run it. Nicely, and it gives you the app with a unique URL that you can share with all your friends. So all of this within AI Studio, it is kind of like a very useful place to go to sort of build all of your things. We have multiple tiers for the Gemini models. I'm not going to go into them too awful much, other than to say that Pro is our largest series. It's also our most capable. Flash is a little bit faster, still pretty great for most of the tasks that you can throw at it. Flash Lite, which is our recent 2.5 release. And then Gemini Nano, which is actually small enough to fit on a mobile device or to be embedded within a Chrome browser. For Gemma 3 and 3N, they've been performing pretty well. So Gemma 3 27B, comparable to the DeepSeek models, but only run on one GPU. So this is one H100 GPU as opposed to 32, which is quite nice from a cost footprint perspective. And then I also want to point out that our latest Gemma 3N model, the 4 billion parameter version, which is super tiny, is actually exceeding the capabilities of Gemini 1.5 Pro. So this tiny little model that is open weights that you can use for all of your projects is better than our best model 6 months ago. So if you extrapolate this out for 6 months from now, you could easily imagine that you can have a Gemini 2.5 Pro that fits on your local laptop, that you could potentially have something like VO3 that's able to be run locally. And this could happen, of course, even faster, given how quickly everything is changing. Cool. So again, interest of time, I'm not going to go into too many of the slides. I'm just going to go and show how you can get started with Gemini and Crew AI. So how many folks have used Crew AI before in the audience? Cool, couple of hands. So this is an example that we have in our main docs. If folks haven't seen Colab before, this is just kind of an environment where you can interact with Python, incorporate it into your projects. Here I'm specifying Gemini 2.5 Pro. I've added in one of the API keys that I have listed as a secret here off in my notebooks. You can define some components. So here, this is just fabricating some example customer support data. You could easily pull in a CSV and summarize it, or you could like have another summary that, or just kind of a series of customer questions, customer bugs that have come in for your products. You define some agents. So here you have a data analyst agent that's responsible for identifying trends and recurring issues and pain points. You can have a process optimization specialist agent, which identifies bottlenecks and inefficiencies, a report writer. And then all of those agents are deployed to solve some tasks. So the first one is to analyze data. The second is to identify bottlenecks and suggest improvements. And then the third is to compile a report to give to an executive via email, such that they would be able to do something about this. Once all of those tasks and agents have been defined, you deploy your crew, you run it, and then it starts this code execution along the way, just executing tasks. For folks who have not ever sort of created an API key anywhere other than like the Cloud Console, a way that you can do it is within AI Studio. So up at the top, you should see a little button that says Get API Key. You click it, you say Create API Key, and then you can either select one of your existing cloud projects, or you can generate one and use it for free, which is behind the scenes still running on Google Cloud. All of the code that you use to get the SDK code is also running on Google Cloud. Cool. So I'm going to go back. We have our customer support fetcher. It's still working. We can see some of the things that it's found. So top recurring issues and frequency, average resolution time. So this is the thing that should be solved. Customer pain points. And then it's doing the process optimization. So it's making some recommendations on things to do. And the final step, which is compiling the executive report, is running right now. For each one of these tasks, it also has kind of a unique code, so you can spot with your logs any of the issues that might occur. Excellent. So this is the executive report to the COO, and it creates a summary with root causes and actionable next steps. So again, feel free to test it out, to try it out. There are 2 QR codes here. So one of them is replicating deep research with Gemini, and then the other one is the Crew AI example that I just showed. So if you want to go and check them out, you can. And like I said, in the interest of time, will not kind of bother or sort of break any more. I will say. I will show one more, so I apologize for fibbing. But this is an example of an agentic task that you could do with VO3 and VO2, as well as music effects. So one thing that I wanted to try is to replicate a commercial that I saw on television.
Hey, my name's Paige, and what makes
this
the
is not me,
Chick-fil-A
Paige.
chicken
This is like some
sandwich
arbitrary
original to
other
me
Paige.
is the crispiness of the breading and the tenderness of the filet. It's tasty, it's warm, it's total satisfaction.
And so to automate this, if you want to kind of replicate this very short commercial using VO2, the process would be taking the video, sending it to Gemini, asking it to segment it into 8-second chunks, then kind of getting a detailed description for each one of those 8-second chunks, extracting out the audio and using Gemini text-to-speech in order to create the voiceover, and then also asking for a prompt for the music in the background, stitching all of that together either with MoviePy or with Camtasia, and then outputting it. So the final video with VO2, music effects, and Gemini TTS was this one.
Hey, my name's Paige, and what makes a Chick-fil-A chicken sandwich original to me is the crispiness of the breading and the tenderness of the filet. It's tasty, it's warm, it's total satisfaction.
I actually liked this one better than the original, but one of my coworkers told me that like clearly it was wrong because this was Popeye's chicken breading. It's not like the Chick-fil-A chicken breading. And then with VO3, it gets even easier, right? So you take the original video, you give it to Gemini 2.5, you ask it to create a really, really detailed example And then you send it to the final video.
Hey, my name's Paige, and what makes the Chick-fil-A chicken sandwich original to me is the crispiness of the breading and the tenderness of the filet.
And that was a one-shot example. So the first 8 seconds, and it was able to generate that from nothing. So there has never been a better time to be a founder, especially a solo founder or a solo builder. So really excited to see what y'all build with Gemini. And again, one piece of homework, go to ai.dev. And if you have any questions, always feel free to reach out as well. Apologies for the technical difficulties, but hopefully this was interesting or useful in some way. Thank you.
Hello, I'll just get the laptop plugged in. Great. I need the slides, please. Yeah, that's great. Cool. Thanks very much, everybody, for coming along to listen to us this evening. So I'm going to give you our second talk tonight. I am David Hewitt, and I'm one of the team members at Pydantic. I've been working in the Rust and Python space for quite some time. I've been with Pydantic since the company began about 2 and a bit years ago. These days, I'm very actively building our Pydantic Logfire product. It's an observability piece that I'm excited to show you a little bit about in a moment. And so, like all of you, AI is exploded onto the scene, particularly in the last year, and I'm playing around with this stuff too. While it's not my immediate, I build, as I say, Pydantic Logfire database. I also get to play with all these things. I'm toying with it, and I'm excited to show you what you can do with Pydantic Logfire to help you do the building. So yeah, that's a bit of a summary of me. Same thing again. Here we are. So yeah, thinking about your agentic app, the first thing that you'll notice is that you've got an AI in the driving seat. You've got something that is completely non-deterministic. And that's quite worrying when you send that through to your users, right? Like, how do you actually understand that the AI is performing as you want it to perform? So it's critical that you have something there supporting you alongside your agentic app, which lets you know what's actually going on. And I talk about performance here in several ways. Is the AI actually giving the users the response they want? Is your application functioning as you expect? Is it functioning fast enough? These are all critical to the ultimate response of what your application is doing. So I want to give you a little bit of a sample of how we think about agentic apps at Pydantic. And in particular, there's 2 pieces of technology which let this happen. So we have pydantic-ai, which is an agent framework SDK. We saw Crew.ai in the last talk, and pydantic-ai is actually a very similar piece of technology, but it's our spin on how it works. And then Pydantic Logfire, which is our observability platform, which lets you see what's going on in your applications. And you don't have to use these 2 pieces in combination. Pydantic-ai is fully functional on its own. You can choose to observe your pieces anyway, or your apps any way you like. We hope you use Logfire. Similarly, Pydantic Logfire isn't built purely for Pydantic-ai. It's a general purpose observability solution you can use to monitor anything that you're doing in production. Of course, we hope that you'll use them together. So what have I done? I went and thought about a toy agentic app that I could build as a bit of a curiosity. I've wanted to for ages. I work, as I say, across the Rust and Python ecosystem. I wanted to know if I could monitor Blue Sky for interesting developments going on in the Rust and Python space. So I thought I'd go and build an agentic app which taps into the Blue Sky network, in particular listening to the Blue Sky 80 Proto is the protocol that Blue Sky is built upon, and the Firehose, getting the events coming out of Blue Sky, and then collecting those, using an agentic app to filter those so that I can ask questions of it, like, hey, what's going on in the Rust and Python space? And in our app, I'm also going to use Pydantic Logfire to see what it's doing. So talking first a bit about how I might go and build that app using Pydantic-ai. It's a Python framework. And so similar to what we saw before, you will go to find, first off, your Pydantic-ai agent. And one of the important pieces in Pydantic-ai is defining what we call the dependencies, or the state, the input that you give the agent that is the context surrounding it. And so here we've got this thing that I've called firehose state. That's the meat of the application that's going and parsing the firehose. I don't want to show you that right now. That's not so interesting. You could go and look at the Blue Sky docs and do that yourself, probably with the help of an AI coding agent. In this case, I've chosen to use Gemini 2.0 Flash and got my API key from Google AI Studio, as we just saw. And in this case, you also feed in a system prompt. I don't want to expand it here because it's massive, but it's basically instructions like, you're reading the Blue Sky event stream, your customer is going to ask you questions about it. You have these tools, which we'll come to in a second, at your disposal to answer the user's questions. And you're going to give the user a string response, so a textual response. But the power of Pydantic AI, if you've used Pydantic as a validation framework, you'll know that we can give you structure to your data. So you can give much more interesting responses, like say, I want to have a prediction with several fields on it, and instead in the output type, you could feed that in as a Pydantic-based model. We'll guide the AI to actually go and produce the shape of response that you want, so that you can then make decisions in the rest of your app. So there's one key tool, which is here in my example, which is filter threads by topic. So I'm going to give the AI the power to call this tool. And it's going to get the agent dependencies, so that firehose state available, the topic as a string that the AI wants to filter. In this case, how much it wants, just 10 threads is enough. And if relevant, you might want to choose the response languages, say, is something else that I gave as a parameter to this function. So whether you care about English communication or Spanish, or maybe you don't mind and you'll take anything. The AI agents tend to work quite well cross-language anyway, so it's not really necessary, perhaps. And this is really just a Python function. You can go and implement the meat of this however suits you and your application. And once you've wired these pieces up, it's pretty much as simple as just saying go. You have a one-time function call, firehose agent run, there's run sync, or if you're doing async code in a web framework, there's run as just a waitable promise-based as well. You feed it in the user query, so what's happening on Blue Sky today? The dependencies, that's the state, the agent dependencies. And in this case, I'm also passing in the previous message history so that we can continue to have a conversation with our agent turn after turn. And we can run this as a CLI program. And then once you've got Pydantic AI set up, Pydantic Logfire can support Pydantic AI trivially. And Pydantic AI Logfire will work pretty much in this way with any of your applications. Once you've installed and imported Pydantic Logfire, it's a one line to configure it. You set your API key as an environment variable. And then it's a bit unfortunate on the way it's divided across the screen. Hopefully you can still read it. It says logfire.instrument Pydantic AI. And that will tell Logfire that we want to go and understand what's going on when we're working with Pydantic AI. But there's calls like Logfire instrument Postgres or Logfire instrument Fast API. So depending on what pieces of your application you're building, we've got lots of connections that are built straight into Logfire. So let's go look at this live. Can we switch over to the monitor, please? Perfect, thank you. Let me know if that code is slightly too small. I think it looks okay. So as we just saw in the slides, we have our Pydantic AI agent which we've imported, the data class we just showed, here's the system prompt, and the implementation of our actual tool as a Python function. Scroll past all of that, we have our main function where we just load up stuff, and then in a loop we can let the user pass in a query here, and then we're just going to give it a shot. And sometimes we get like a flaky API error or whatever, so we retry sometimes. We should be able to go over here to our terminal. There we are. And run this. And so in the demo, or the diagram I showed you at the beginning, we talked about listening to the Blue Sky event firehose. Obviously, for a demo purpose, that's not actually practical. So what I did, I captured about 15 minutes of the Blue Sky firehose, and just as the app's loading, it's just replaying basically the messages that I recorded in that 15-minute window. I think it was like 200 megabytes or something. So it's going to take a moment to start up. Obviously, if I was running this live, I'd probably have it deployed somewhere in the cloud 24/7 and just let it keep the last 12, maybe few hours of messages in history. So here we are, and now that we're live, we could take a prompt, something like, what's interesting in software engineering today, give it a bunch of terms that we want to know about, AI, Python, Rust, Google Gemini, maybe MCP and A2A, and we'll hit enter to fire that off to the agent. And the agent is going and doing work. And while it's working, we can see on Pydantic log file right here, the run that we've just launched and what we've said. So that's actually going straight to the output, but we can see from the beginning what pydantic-ai prompted from our system prompt the AI agent to do. Okay, let's go to full screen, sorry. And so then what happened is the AI agent decided to actually split this up into 6 different tool calls. So these are all for different topics, one topic for AI, one for Python, one for Rust. You get the point. And what was interesting when running this application, most of us think of agentic applications being limited by the AI as the performance bottleneck. But here, we're actually already hitting a bottleneck in Python. We looked at 15 minutes. I said I'd quite like to have hours potentially of message data. It's already taken me, on the worst case for this one, 12 seconds to respond to actually just feeding data into the AI. And it's quite important that we can filter the information down, because you can imagine otherwise hours and hours of messages is going to be way too much for the AI to do anything. So then it becomes a question, well, how do we optimize this? And so, having mentioned previously, I work across the Python and Rust space. I see a hammer that I'm going to hit every nail with. I'm going to go use Rust. So what I did, I went and took the Python implementation that we have of this, and I added a Rust implementation that translates pretty much the same filtering logic, but it's just doing it in Rust instead of in Python. And so if we restart our agent, I can this time instruct it to use the Rust implementation that I wired up. And so we're going to have to wait just a moment to get the replay to complete again while we do that. So in the logfire UI, the interesting thing that we can see, as well as the individual time for each tool call, we get the previous history. And this is, again, I'll emphasize, I've just put instrument pydantic-ai. I haven't added any other instrumentation to my app. I could put more log calls into here or choose critical points that I actually wanted to monitor myself. We'd get more and more interesting traces coming through every time we ran each of these. And so if we go back, okay, we're ready. So let's paste in our same prompt again and hit go. This time we should see the response serviced, hopefully a fair bit faster. There we go. And we can see again that we've just had this come through in Pydantic logfire. And this time we can see that the Rust implementation has indeed serviced it significantly faster. So I'd hope that my toy app is then going to scale to hours of data without becoming prohibitively slow. So that's all on the demo. Can we switch back to the slides, please? Thank you. So really, to summarize up, your app is going to be unique. It's not going to be that you can take a handy problem like this where it turns out that Python filtering is a bottleneck and just shove Rust at it. You're going to need to know what happens in your app. And so the point of Pydantic logfire is that it's giving you that insight into its operation. Rust, in particular, removed the bottleneck from filtering the event stream in my app. And what was really interesting is that actually, while it sounds like a bit of an esoteric thing to use Rust, it's actually all over my application before I even started. The AT-Proto SDK, which does the blue sky event parsing, turns out that's implemented in Rust for performance to do the parsing. And then, of course, you're all likely to have used Pydantic. Pydantic is doing the data validation in Rust. And actually, this is so common that I went for dinner and told an AI agent to do the translation of my Python filtering function to Rust for me. And it went and pretty much one-shot the entire thing. The only thing it fell on was a slight performance trap that in Python, a regular expression for doing the filtering, there's a few regular expressions in there, they're cached. So if you recreate the same regular expression, you get the same thing back quickly. In Rust, that doesn't happen by default. So the AI's attempt actually ended up being a teeny bit slower because it was doing a lot of recreation of the same regular expressions for every single message. So having a quick look, you can actually instrument Rust code in Pydantic logfire too. In this case, I could just see and fiddle it around, but you could dive in deeper yourself if you needed. And that's pretty much what I wanted to show you today. Thanks for listening.
Nice, thank you very much. Is that working? It is.
Pydantic is all you need. MCP is all you need, should I say. So this talk is an update on a talk I gave at AI Engineer back in June. And indeed, it is inspired by my friend Jason Liu's talk, Pydantic is all you need. Then apparently that wasn't good enough, so he also did Pydantic is still all you need. And it really has the same principle that people are overcomplicating things. And actually, we can often use a single, simpler tool where people are trying desperately to shoehorn in complex tools. And again, very like Pydantic is all you need, it's also completely unrealistic. No one is claiming that Pydantic can actually do everything, and of course that's true with MCP as well. All I'm really trying to get at is it can do a lot more than people think. So particularly in regard to multi-agent systems and communication between them, particularly autonomous agents, MCP can do lots of things. So I'm going to talk about one of the more advanced features of MCP, and obviously show you what that looks like in Logfire as well. So how? MCP wasn't primarily designed for this kind of agentic application. It was designed specifically for things like Claude Desktop or Cursor or coding agents where Anthropic are making their money and they're where they wanted to have something to solve this problem. But it turns out that we can use it. However, MCP has three primitives, prompts, resources, and tools. Prompts and resources aren't particularly applicable in this context, but tools, the last one, really are. I think one of the things people often say when they hear about MCP and tools is, why can't it just be an open API schema? Is that like, why do we need this protocol for it? And I think that there definitely are cases where you could use an open API schema, but there are lots of more complex things that MCP can do. Dynamic tools, logging while a tool is running, so basically returning to the user information, tracing, which I'll show you today, what they call elicitation. So that's basically asking back to the user for more information while you are running a tool. And lastly, sampling. Sampling is perhaps the most poorly named concept in recent technology. This is not sampling as any of you think of it. It is not sampling as you think of it in observability. This is the concept of being able to, in fact, I'll talk about it here. It is the concept of being able to perfect line through my line describing it. It is this concept where the MCP server is able to use the LLM provided by the client. So instead of you having to provision all of your different MCP servers with their own API keys and have their own quotas, et cetera, you can simply call back through the client to make the call to the AI. So you can kind of see the flow here. We start off with the MCP client. It'll call the LLM. The LLM will say, OK, I need to call this tool, which happens to be an MCP server. The client will take care of making the call to the MCP server. The MCP server will decide it needs to use Gen AI. Its call to AI will be routed back through the client to the LLM, returned all the way back to the MCP server, and then finally that tool will return and the MCP client can finish. Now, as you can see, this is a relatively complex flow of data. There are lots of things to go wrong. Many of them you may see go wrong in my demo in a moment. But this is where Logfire becomes really handy, where you can see this distributed. You can use our distributed tracing to understand what's going on as we're making these calls. So I've whizzed through that first bit because I'm not here really to sell MCP. I'm here to talk about the stuff we've built. But I think we can take questions at the end if I've fast-forwarded through MCP. I realize I didn't give any intro on it at all. But hopefully it's ubiquitous enough by now that you all at least heard of roughly what it does. So this is a Pydantic AI app or agent designed to go and do research on Python libraries or on libraries in general. So it has access to two tools. Well, it has access to many tools via two MCP servers. So one of those MCP servers is just GitHub's MCP server. And the other one is this PyPI server. So the principle of this is that it allows us to go and make queries against the PyPI data on downloads from packages. Now, to do that, we have a public data set on BigQuery where we can go and query data about Python packages. However, that needs to be written in BigQuery SQL. We need to know the schema of that table, know what table to go and call. That adds an enormous amount of information to our context. We don't want to put all of that into the context of our agent. And you can imagine here we just have GitHub and PyPI, but if we imagine we were going to add crates and NPM and lots of other things, now we're suddenly getting to some enormously complex context. Our agent is going to start to degrade. So instead, we can use tool calling and in particular sampling to reduce the amount of context we need to put in our primary agent. So if I look through here, I'm just going to walk through it quickly. We're using Gemini. We have a PyPI server, PyPI MCP server, and a GitHub MCP server. The way that Pydantic AI implements MCP is we have this concept of tool sets where you can register multiple tools that can be dynamic. MCP servers just implement that protocol, so we can add our own tool sets or we can use MCP. We have some very simple instructions. We're setting here that we want to use the default model when we do the sampling. So when the call comes back from the MCP server, we want to use the default model. We could set a custom model here if we wanted. We're going to add a bit of custom instructions or dynamic instructions. So this will be called on each invocation. So we have the current date. And then here we have the actual call. So we have a logfire span around it, which will just make it easier to view what's going on. And then we have this async with agent starts our MCP servers or connects to our MCP servers in the case of HTTP ones. And then we're going to make a very simple question. And obviously, I'm a complete narcissist, so we're going to ask, how many downloads has Pydantic had this year? Not enough people laughed. I think maybe they thought that was real. And so then we have our MCP server. I'll just go back here, actually, and explain. So this MCP server here is running locally. So it's going to be run as a sub-process, what MCP calls standard I/O. So it's literally going to communicate over standard in and standard out. But it's going to be run as a sub-process. But obviously, this would work equally well if this was running on over HTTP. One of the nice things about MCP is you can switch from standard I/O to HTTP, generally with minimal code. But this introduces a complexity because we're going to have our main process running and being traced, and then we're going to have a sub-process running. And one of the really nice things we get from this line here, where we've instrumented MCP, is we're going to get distributed tracing. So we're going to be able to see logic going on within our MCP server in the same trace as our MCP client, and that should all display nicely. So going into our server, we again have instrument MCP, again instrument Pydantic AI. We've just set the service name so that we're clear which service we're seeing traces from. We have our BigQuery client, and then we have the instructions. And this is what I mean by there's loads of context here that we wouldn't want to shove into the context of our main agent. So there's the full schema for the table, some example queries, information on how to use timestamp, et cetera, more example queries, yada, yada. Again, we're going to give it access to the current date, so it doesn't have to. So it'll be accurate about what the date is. And then in this case, we're going to use an output validator on Pydantic AI. So this is a function that will be called as the agent finishes, and it's going to actually make the query to BigQuery, make the request to BigQuery. One of the powerful things about doing it this way is if our SQL is invalid, we can raise the model retry error, and the LLM will get information about how it failed. Either this instruction used the correct table name or the actual error from the query. It can then go and use and fix itself. And I'm amazed at how often it's able to use this technique to actually go and fix itself. So now we get to the MCP bit. So we have an MCP server, and we register one tool, PyPI downloads. That's the tool name that will be visible to the top level agent call. And then we're just going to run it here. I just added this code is just so I can run this particular file independently to try it. So if I go and run this example, and the gods of demos are with me, we should see. So we'll see logfire printing out as those tools are being called. And while it's making those calls, I'll come over here. Oh, that's a bit embarrassing. That's a chart of downloads of Crew AI versus Pydantic AI. Didn't mean to show anyone that. And sure enough, our agent has indeed finished, and we can now look at what's happened. So we have, this is the trace of our top-level call from the client. And what you see here is we're switching between the client and the server as we go along. So we're making any tracing from the server is visible within the same trace. So if we get to here, this is our actual agent run with Pydantic AI. You see we have nice stuff like the price that we got charged. Here we paid 0.6% to Google. That'll help them. And you see that we called this tool, PyPI downloads, asking how many times has Pydantic been downloaded. You see here we didn't have to write the SQL in the main agent. We didn't have to do anything complex. We just asked it a very simple text description of the question, and the tool returned the value, and then we printed it. Now, the interesting thing to do is to say, in here you see we're calling one tool, what tool that is, then we call that with MCP, and then now you'll see we're in MCP server. So we've actually have distributed tracing where our tracers basically immediately switched over into the server. And so within that, we then call Pydantic AI again, and now we have the other agent running, and see how this has way more context. So it has all of this stuff I showed you earlier. It then got the input that we saw before, and it's returned that SQL. On this particular occasion, slightly frustratingly, it got it right first time, so you don't see the retry, but it would occasionally fail. And then you see the SQL that we went and run, so we can actually go and look and check that looks about right, which it does. We then have OTel instrumentation of BigQuery. So because Logfire is built on top of OpenTelemetry, we don't have any specific support for BigQuery, but BigQuery is instrumented with OpenTelemetry. And so we can see how long the calls to BigQuery took. And then we eventually return from this tool, and we go back and we have one more call to Gemini, and sure enough, it outputs the final value. And just to show you and to see if it works, I'll do one more example. So I'll clear that. I'll come back over to here, and I'll try a different query. So we'll ask it, instead of looking at the PyPI, we'll ask it how many stars does Gemini CLI have? And now that's running, and we can see in real time here, if we go live, this call to, we see we have information about the trace as it's going on. We can see what's taking time. You can see we've got this call to the agent. We made a tool call. In fact, one of the interesting things to say here is you can see within Logfire all of the tools which the GitHub MCP server registers. And what tool we then chose to call. And sure enough, if we go and look at the top level agent run, we should see at the output at the end, lots of stars. But the interesting bit here, I think, is the detail we get about what's gone on. And if we got an exception, we would have information about that, exactly where it's happened, et cetera, et cetera. Thank you very much. Can we go back to the presentation? So that's what I've got today. The code from my slides is there at that link, or just go to Pydantic/talks on GitHub, and we have all the talks I've given. I'm going to be around, so if anyone has any questions, I know I've gone quite quickly through some of the MCP stuff, please come and find me. Thank you very much.
Hello, everybody. How are we doing today? Come on, it's announcement time. I think we can do a bit better than that, surely. Come on, how are we doing, guys? Fantastic. So hi, everyone. I'm Fabian. I'm one of the startup architects in the early stage startup team. And so I have the pleasure of working with some of our early startups to help support them adopt Google Cloud products and technology. For the last year, I've had the pleasure of working with Pydantic. And it's amazing to see all the exciting stuff that they're building. But today, we would like to announce something that we're very excited to share with our Google Cloud customers. And I'll pass over to Chris to give some details.
Thanks, Fabian. I'd like to start by thanking our host, Google. Thanks very much, guys, for putting on this great event and feeding us. We really appreciate it. So, announcement time. As of today, this evening, you will be able to purchase Pydantic Logfire through the GCP marketplace. And for those of you with large procurement departments, you'll know that that will make things a lot smoother. And for those of you with cloud budgets, you'll know that that will make things easier to get through all those budget committees. So if you search for Pydantic in the GCP marketplace, it's now there. Hopefully, having seen some of what Logfire can do through the talks this evening, you'll be interested to check it out. The Pydantic team is going to be down in the cafeteria. We'd love to talk to you about any questions you may have. In particular, if you're interested in things like self-hosting, please come and chat to me. And then the other thing we'd be really interested to talk to you about is an AI gateway. Anybody who's interested in that, we'd also love to talk to you, something we're thinking about pretty seriously. Without further ado, that's the announcement. And now I think we're ready for Q&A, and Mike from Google's going to be chairing the Q&A. Over to you, Mike. Thanks very much.
Cheers. It's a PR code. Perfect. Thank you. Hello. Can we have Paige, David, and Samuel come to the stage? Right, questions. If you've got a question, raise your hand. Really quick questions. Let's not hog the mic. Right, first question. Keep talking. I'll do some ad-lib. How's everyone doing? Questions? I've got a question. No, I haven't. But is it working? Why don't we use the handheld for now, and then, yeah. Give it that for now. Grab that one.
Hello? Yeah.
There we go.
That works. Okay, cool.
We tried to be cool and edgy with a cube mic, but clearly.
I was looking forward to throwing that to someone. Hi, Rob from Engramic. Thanks everyone for the presentation, really great. And thanks, Pydantic. I think you have brought a really good view on kind of a structured way of building these types of programs. And I'm curious, as we get into the agentic era of building programs, there's observability when we talk about the performance of the code and how fast it's running. There's observability in terms of how the LLMs are actually performing, how we evaluate performance responses, things like that. What is a Pydantic version of that kind of non-deterministic evaluation for these types of projects?
Yeah, so we have Pydantic evals, which is part of Pydantic AI, effectively maintained in the same repo. It has some weak connections to Logfire, so you can display a run within Logfire, but we think I would never have used PyTest if it was somehow linked to GitHub Actions or anything else. So we think that if there's going to be a really good open source evals library, then it has to have be usable without a particular platform. And so yeah, Pydantic evals is a big part of that. But I also think I gave a talk, human-seeded evals, which is, there are two versions of it on YouTube, one of which is me talking about something completely different due to a slight mess up on timing. So you need to look for the one with Hugo. But that is, I think, our view. I think evals are a bit like flossing. Everyone talks about them. Not many people actually do them. Yeah. And I think that part of that is we need to make them easier to do. And so the principle of human-seeded evals is you go into Logfire, you basically annotate a few cases where the models behave well or behave badly, and then we can use an agent to go and start applying other evals, and then you get performance without having to go and write all the code. But if in the cases where you want the full-on eval setup and data sets and runs, then Pydantic evals.
Amazing, thank you.
Fantastic.
Who's next?
We have one more question. We're going to go to that. Yeah. Why don't we go question up front? Amy, should we go to that side? Yeah. You got to catch it, by the way.
Can you hear me?
Yeah, we can hear you.
So we saw Paige demoing the live API from Gemini earlier. So Samuel, are you going to build abstractions about live or real-time API into Pydantic AI?
That's a good question. I was actually watching it too and wondering whether we should. I think we'll be doing embeddings next. I think that's the first thing to come, and then we'll have a look at it.
Perfect. We've got a question here at the front.
Is ADK on the roadmap for an integration?
So Google ADK already has OpenTelemetry instrumentation. That's great. All it has is token counts. I know Aaron Abbots from the Google team joins the OpenTelemetry SIG every week and looks a bit embarrassed by the state of it. So I'm hoping it will get its own instrumentation. I mean, more generally, without going into all of the details, the OpenTelemetry semantic conventions the Gen AI semantic conventions for OpenTelemetry are evolving. They are just in the process of settling. Once they settle, in theory, you will be able to instrument any agent framework, and it will look nice in Logfire, and then equivalently, you will be able to instrument Pydantic AI, and it will look good in any other platform. The interchange between the two is getting there. It's not quite there yet.
Perfect. Who's got the next question? Where's the cube ball?
Okay.
Why
Cube
don't we
ball?
do-
Oh, no.
but
It's too
Dennis,
hazardous, sorry.
Up on the left there.
Oh, yeah.
Yeah,
You
that's
go
a
out.
short throw. There we go.
Oh, hi. Yes. The Logfire offering via GCP, how does it do? What kind of self-hosting options does it have? Because specifically for PII in traces.
So as I understand it today, the option to buy Logfire through GCP is just the cloud version. If you want self-hosting, we sell that. I don't think we yet can.
It's on the roadmap. It's on the roadmap.
It's on the roadmap. We will soon allow you to buy it through GCP Marketplace as well. But we already offer it, but not through the GCP Marketplace yet.
Just by interest, how many people are interested in Pydantic through the marketplace? I guess there's a couple. There's a few hands. Okay, cool. That's good to know. Right, who's got the next question?
Is it me?
There we go.
Hey, this might be a question for afterwards, but you know when you looked at the agent, how it actually does direct access to the database, do you have good tooling for limiting what it has access to? Because immediately that gave me a heart attack, and I was like, what if it starts reading tables I don't want it to have access to? What if it starts exposing customer data, for example?
You need to implement that. We're not going to...
So afterwards, we'll have a chat.
Some of the other agent frameworks are very overbearing in the sense they try and go and give you abstractions for all this stuff. Most of those I wouldn't trust. We only build things that we would use, and we don't think that there is the right level of... It's too tailored to the particular application. So you use row-level permissions, use read-only access, use that stuff, do it yourself. That's the safe way.
Cool. Thank you.
Great. Who's got the next question? Amy.
I'm hogging the questions. Any questions for anyone else?
Jump. No, joking. All right. Got a question at the back here, and then we'll come to this guy at the front.
What does embeddings look like in Pydantic? Can you give us a few sentences?
I mean, I think it'll be an interface to generate an embedding. I mean, I have spent a lot of my career trying not to build an ORM, and I may fail at this hurdle, and we may have to build at least a minimal ORM to let you do the vector search, which so often goes with embeddings. I mean, one of the reasons we haven't done it so far is that the basic interface is very simple. You give it some text, you get back a vector or a list of floats. Good question. If you have any thoughts or what you want, please come and talk to me.
Cool.
Hi, Fergus from Ganesha. I've built and deployed a variety of different agents, multi-agent systems out in the enterprise environment already over the last 2.5 years. A lot of that's built on LangChain, LangGraph, but using Pydantic for the state. So there's some Pydantic there as well. Really love the look of Logfire. Haven't tried it yet, but is it possible for me to effectively implement that on all these existing systems that I've already got deployed? Is it backwards compatible?
Yes. So we have instrumentation, for example, the OpenAI SDK or Google ADK to what they have. And so you get the raw LLM calls. There are basically, without going into too much detail, LangChain have their own thing that is not OpenTelemetry, and they would try very hard to stop people instrumenting their libraries with OpenTelemetry, but numerous people have tried. And so I think basically now it will work. It won't look as good as with Pydantic AI, but you'll definitely get the core details. It just won't look as pretty as Pydantic AI.
Makes sense. I'll give Pydantic AI a go going forwards.
Just a little plug. If you are interested, there's a QR code there. You can scan that, and the team will be in touch after. Any questions for Paige or David? Any questions? They're standing here. No questions. We got two. There we go. In the middle. Over there. In the middle. Yeah. Just watch the projector.
Mic check, 1, 2. Okay.
There we go.
So my question is around on-device LLMs. You mentioned about the Gemini Nano, and said you could work on Chrome and the like. So how far away are we from using the Gemini SDKs to actually interact with on-device LLMs?
So you can use. I guess there's a microphone here. Hopefully it works. Does this one? Yep, excellent. So you can use some of the smaller Gemma models with the Gemini SDK today. Of course, they aren't self-hosted. They're just models that you would call the same as you would make any REST API call to hosted Gemini versions. But you can use local Gemma models with all of the open frameworks that you're probably familiar with. So Hugging Face, Ollama, etc. On your local devices. We do have a version of Gemini Nano that's baked into the Chrome browser. So if you wanted to use those existing APIs, you could. And then there's also a way for you to run Gemini Nano and some of the smaller Gemma models using LightRT and using MediaPipe, which is kind of an open framework for running models on devices. So you can already run these tiny models on devices, just not using the Gemini SDK, using like other SDKs. Yeah.
Cool. Got a question at the back?
Oh, he's got it.
Oh, someone's
Sorry, can I go?
Sorry. Yeah.
Okay, so this is partially a request and a feedback for Gemini 2.5 series. I've been really struggling to get it to output longer arguments in tool calls. And after many hours of debugging what the hell is going on and obscure errors, turned out that I'm not alone, and there's actually quite a lot of people struggling with the same. So those malformed function calls, as they're called in Google, it would be incredible if it could be captured what the problem actually is, why it's struggling to output a schema, so helping people understand how they can avoid them, if you understand it at least a little bit on your end. And in general, just like squashing it. Like, it does get better with stronger models, but it still happens way too often.
I agree. There's a lot of work that we need to do on function calling and tools use for the Gemini 2.5 series, but the team is working on it. There should be some updates coming soon, especially for things like structured outputs. But if you send me the problems that you've been experimenting with or the problems you've been experiencing and the GitHub issues that you filed, I'll get them surfaced up to the team. And I'm just at webpage@google.com.
Perfect. Right, we've got a question up front here. Right.
I've used Google's ADK to build a really cool project, which is amazing, and Pydantic seems like a really amazing thing. But I'm just wondering, like, so my company has some data across different AWS, like some is in GCP, some is in AWS. So is there like a guide where I can essentially just start experimenting with data in a safe way? Because I mean, like, I can run these things really cool on my laptop, awesome, amazing, but when it comes to enterprise data, like, it's a little bit more complicated because it needs to have that. So is there a guide or something like that, or any resource you could point to?
We don't have a particular guide, and we don't have a hosting solution yet, so Paige?
So I do not work on the ADK team. However, we can definitely get the feedback back to them. Google Cloud does offer many solutions for people who are working in multiple cloud environments, and that sounds like something that other folks would be really interested in as well. So thank you. That's a great example use case, and we'll get that to the team.
Best solution is just migrate to GCP. Right, next question.
Wait. If the guy would just ask the question, talk to Ben afterwards.
Yeah,
because we got two Google engineers over here so that they can help you.
There's a French guy there with lots of answers. Right, next question.
Quick question. Fine-tuning for embedding models used to be available for the Gecko models. With the new Gemini embedding model, do you anticipate fine-tuning being available for it? And then also, generally speaking, for fine-tuned models, how right now they're only available for the length of that model. If we wanted to, for example, pay for PTUs, would we be able to kind of extend that?
For the Gemini APIs in AI Studio, we're not going to be investing in fine-tuning going forward, just because we've seen most people for the evals they create and the results that they would like to capture get a lot of success out of just using the Gemini models plus tools, or the Gemini models plus something like retrieval, being able to use the reasoning phases to orchestrate more complicated commands or to chain model commands. And that gets kind of better results than the existing fine-tuning APIs, which were all just kind of like LoRa fine-tuning behind the scenes. They also had some strange constraints around, like, one of the nice things about the Gemini models is that they have 1 million or 2 million tokens for the context window. If you do a fine-tuned variant, then suddenly the threshold for the input tokens drop down to like 32K as opposed to 1 million or 2 million. So we've seen most people kind of shy away from the fine-tuning APIs for the Gemini models. If people are fine-tuning, they're probably fine-tuning a Gemma variant. So that's kind of the AI Studio answer. I do know that Vertex offers some fine-tuning capabilities, and so if you do want to fine-tune, Vertex would probably be the path to go look at. But strongly recommend experimenting with things like retrieval or even just kind of multi-shot prompting within the context window to try to get the results, because the models are improving pretty rapidly.
If you have fine-tuning questions on Vertex, Ben, wave your hand again. Speak to Ben. All right, question up front.
Yeah, hi, question for David on the agents. If I was like using multiple different agents and multiple different tools over time, is that something that Pydantic AI is going to like look at and give me information on and say actually like, you know, based on user feedback, like actually use these better tools or use these different agents and kind of like learn over time essentially?
So what, in agents in this context, you're thinking about different AI models, or like what kind of feedback are you looking for?
Like choosing the right agents or choosing the right tools. If it's different agents.
I think that we already have the like hook points to decide which tools are registered at which time. I think like that's where the kind of like more complex case of evals comes in down the line, where you want to go and work out exactly what tools you want to have registered at any one time. I will say the other thing that we didn't demo today at Logfire because we didn't have time, but you can run full SQL against the Logfire database. So fundamentally, Logfire is just an analytical database strapped onto the back of your application, so it sees everything that's happening. So you can go and run a query to say which of these tools have been called how many times, and then you can go and say, well, the bottom tools that have never been called or have only been called a few times, I'll switch them off.
Okay, last question.
Hello. Oh,
yeah,
a question for David. This is a question. Like Rust has some good beginner intro documentation, but it's easy to get started with, hard to master. Do you have any quick suggestions for resources that one could look at to kind of for the intermediate and advanced level of?
So a resource that I get glowing feedback on all the time is that is this mic still be on? So the one resource that I hear a lot is the Rustlings book. Or it's like a set of problems that like try and introduce. So there's a Rust reference that like will give you a very reference heavy material on it. But then the Rustlings is trying to teach you through like set problems that like introducing the cases one by one. So you'll go from like a very basic hello world through to like more sophisticated things where you're getting into the grips of like what's really going on in the various Rust language features. And that's one that I hear again and again. That when people are like going back to Rust, they're like, oh, I really need to try Rustlings. And then the other one that people come across a lot is the advent of code. Obviously comes in every season, and I hear lots of friends who tell me like, oh man, I always want to do Rust too, David. And then they're like, this year it's like advent of code year. I'm going to do as much of the advent of code in Rust. And you know, inevitably everyone's busy and they don't get to try much, but it seems to be like a great seasonal option. Personally, like feedback that I also hear, like I produce an OSS library called Pyo3, which allows you to step from Python into Rust, as we saw in my talk. And I get a lot of feedback about people who are like Python programmers who are like, man, I had this thing that just wasn't quick enough, or you know, for whatever reason, maybe it was that they needed to reach into the hardware in a way that Python couldn't do. Or one thing that Rust is also really like famed for, once you actually look at it, is its reliability as well. Like Python has a lot of like runtime behavior that suddenly spooks you with exceptions that you never knew could even happen. And Rust just tends to not have that property. And so people have like tried Rust for a particular problem that they wanted to solve through Pyo3, which gives you like a very gentle window where you know you're solving a function in a domain where you've already written the Python solution or whatever. So you can really model it. And especially with AI tools, as I said, for translating from one to the other, it can really help you get there. And that's sometimes like a gateway for some people of like, oh, I did that and then I did some more and now I just keep wanting to write Rust code or whatever. So
I'll
that
say
can be a way in too.
I'll say that I was not by any means an experienced Rust developer when I started rebuilding Pydantic in Rust. And 8 months later of doing nothing but that, I was quite good. But it was Pyo3 in particular. I mean, among other bits of the developer experience in Rust is great. Pyo3 is a great part of that, but that allowed me to get started where I thought, you know, I haven't done any low-level language since university, and I was able to not only make it work, but also build something that people actually find useful. So, yeah.
Fantastic. Right. I know many of you are going to have a ton of questions. We've got plenty of time for networking. The Pydantic team will be downstairs in the networking zone where we were earlier. So please come and ask your questions. You have a few of the Googlers here, custom engineers, AI experts, who will answer your questions on fine-tuning, Gemini, and obviously Paige and David and Samuel will be downstairs. So can we just give our speakers a round of applause, because that was fantastic. Okay, cool. Right, so we've got a little bit of a logistical, not nightmare. Right, we're going to go back down to the 8th floor and then continue the networking. So we're going to take the same route back downstairs. There's still drinks. There's still some stuff left. Enjoy. We still have some time to network. And also meet the Pydantic team or ask your questions. And then hopefully be home and back in bed by hopefully 10 or 11. But anyway, we'll see. Fantastic. Have a good night.